Today we're diagnosing a completely dead iPhone 14 Pro Max. No charge, no power, zero response. I'll walk you step by step through the investigation process from detecting a main rail short to deciding what can and cannot be repaired. This is a real-world diagnostic workflow. In this video I'm gonna speak about how to diagnose a phone that has charging issues and do not power on, so a completely dead phone. And for this we have here under the camera an iPhone 14 Pro Max. I think it's a 14 Pro Max. Yeah, it seems like a 14 Pro Max. I've already removed the display and the big shield covering it. So first thing first, what we can try is to power it via USB, and you see here the USB supply right here where it says 5 volt. I'm gonna plug in the power and we watch the amperage draw, and we see it goes to 4 milliamps, goes back to 0, 4, 0, and it keeps repeating, right? So this doesn't tell us much. It probably tells us that it has a short circuit. Now I'm gonna remove the screen because I think it's easier to see it from above without the screen here. So the screen is disconnected, right? If we power it on via the USB supply, via the power supply using the battery connector, and we don't notice a short, then we put the display back. Maybe there's a short here in the front sensor. Good. So I'm gonna take the power supply cable, which is very short, and the power supply is on the far left of my desk, but I think we can manage to get it somewhere around here so we can also see the top picture, right? So I have the power supply connected, and now we can look. The power supply we're gonna use is the first one here on the left, and I'm gonna turn the power on in 1, 2, 3. And we see an instant current drop of current draw of 3 amps, right? So that's a lot of current. I'm gonna disconnect all the flexes. Maybe I will not disconnect. I think this is the power button, so I'm gonna leave the power button. Actually no, let's disconnect everything because the short was on one of the main lines. Otherwise it wouldn't have appeared when only when I press the power button, but if it appears exactly when I turn on the power supply, then it means that the short is on the main line, which is, I don't know, one of the main lines. I thought better, main lines, because we have the bat line, then here is transformed in this chip under this shield is transformed in main, and then we also have a VDD boost circuit that is also one of the principal lines. So I have everything disconnected just to exclude anything on those flexes, and I'm gonna power it on again in 3, 2, 1. Yeah, and we still see the 3 amps current draw. Now I'm gonna remove completely the motherboard, remove all the foam, remove everything that's on the back, and we go under the microscope and we'll have a look further there. Probably we'll get the thermal camera because it's easier with the thermal camera, and we can scan the board and see at least where the heat is coming from. We can remove these foams. I don't know how they are called, but we don't need them anymore. The one around the battery connector was already missing. Yeah, we have this one. I'm gonna also remove this one because I have the feeling that we're gonna have to split the boards, but we don't. Never say never, you know. And I'm gonna remove also these on the sides. So for the next step, these are not important on the sides because they don't prevent us looking with the thermal camera at the phone. And this one on the back I'm gonna have to remove also, because I want to see if the heat is coming from the top board or the bottom board. So I'm gonna use some hot air, like 350, and I'm just gonna slowly heat up this pad here, so we can easily remove it. Not too much. Good. Now let's see. I would like to remove it without losing the bottom sticky part. Okay, I don't like how this is coming off, because I have a piece here that remains on the board, and I would like that to come off also. Yeah, that's a bit tricky on this 14 model. Okay, so this has been removed. Let me put back this crap here. Okay, and we can leave it aside. Good, now we have to remove this thingy. Not necessarily, but if I'm gonna split the boards, and as I said, I have a feeling that we'll have to, then okay, we have everything removed. Let's see what's heating up. Yeah, nothing really here, but I have something heating up right about here. See? So it's somewhere around that shield. I can't tell if it's under the shield or it's below, between the boards. See there? Now you're gonna notice something else. This will heat up this area because this is producing the main, but we need to ignore that and we need to follow our short. See how it's heating up? Now what can be heating up there? So it should be somewhere here, and we have 1V24S0. That's not a main line. This is 0V33 NAND. That's not something that we care about, and this is a main. So this is the only one, and this here on the other side, that could heat up, and also one of these here. I'm gonna cut this shield, so I'm gonna cut that part off. If I can find my Dremel, yeah, it's right here. Let's do some cutting. I prefer to cut it and then go to the bottom, go to the other side if we don't find anything here. I'm gonna cut here like this. Yeah, these are quite easy to cut. I would really like to have one of those lasers I see on Facebook, but they're extremely expensive, the ones that are used to cut these shields. Okay, so now that it has initialized, let's see. No, so the problem is on the other side, see? Problem is on the back. Yeah, unfortunately. Unfortunately, we have to split the boards. I've cleaned the boards, so boards are split. I've cleaned them already, as you see. This is prepared, and the bottom board I also reballed it. Look how good it looks. It's like factory. This is extremely perfect. Okay, let's get back to our board. So you are seeing some heat coming over from here, and here is the main PMIC, which I don't like. I really don't like. See, so the heat is coming from somewhere around here. So if it's that kept there, it's gonna be a bitch to remove. Okay, and let's see what's heating up. Let's see careful. Oh, this is no bueno. This is no bueno. You see there? Mother. So that is the PMIC directly heating up. That's bad. That's so bad. Yeah. And we have the CPU heating up. Oh la la. Oh la la, that's not good. 3 amps and the CPU is getting hot. Alright, so next day, prepare to tackle this one. So first of all, when we have a chip like this, we need to be aware that the underfill is extremely hard around this one, and it's very heavily underfilled. Also the parts around it, you see that underfill comes up to these coils and after them. So you have this row underfill, this row of caps, this row of coils. So if we apply a lot of heat here, the solder will get away under the coils and make their way somewhere else because of that underfill, because the coils cannot move, they are like stuck to the board. Yeah, so it's a bit difficult. I would advise here to come with a small nozzle and just pry this off. Concentrate the heat in small portions and pry this off. So when we attempt to remove a chip like this, we're also interested in the architecture of the board, because we need to know where the heat will be sucked more, and for that we need to look also what parts we have on the other side. So if you look like this, we have here the NAND, yeah, which is a very big one that takes a lot of heat. We have this shield that will also suck a lot of heat, and here up we have the Wi-Fi chip. Yeah, but it's a bit upper, so it doesn't reach our chip. But if I look like this, yeah, we have this chip like that, and the NAND. Here in this area we have the NAND. So here is the NAND, here is no NAND. We have a bit of a shield like this here. Yeah, so this part will take less of the heat. This will take a bit more of heat, and this half will take also more of the heat. So we need to make sure we're gonna tackle this right. Then we're gonna have to pry this off somewhere. So most probably we're gonna have some trouble with some parts around it that we might move. Now I've seen people that actually scratch this off until they get to the glass chip, and then use a big solder iron. This is the biggest I have, so it's not very big. I don't think I can manage this one. Maybe put some kind of how is it called, this one, with a lot of solder like this, and this will spread the heat onto the chip this week. Yeah. And I seen them doing this and then prying it off. So they do this until the chip gets very hot and you can pry it off. I don't know if we should try this or not. I've never done it. I don't have a bigger tip than this one. This is a 245 chisel, so it's the biggest one I have. No idea if we should try this. I never did it. But first of all, we need to actually remove the underfill around the chip. So for that I need a heavier holder, and I'm gonna mount this in the holder, this board. I need it to stay very well there. Yeah, so I'm gonna start with this corner with a sharp 11 blade. And probably I'm gonna set the temp to like 260, 250. Let's try 250. 250. Let me get the tip, and I'm gonna first hit the entire board. Because it's cold, it hasn't been worked on today. Okay, let's see how it goes. I'm trying not to push this blade inside because it's very sharp and I don't want to scratch the board. Yeah, I have another option, like using this hook here, but these parts are so close to the chip, I'm afraid I'm gonna bomb them with this because this is not very sharp. I think it's gonna work. This blade is a bit thicker than the blade from the knife. Let's see, maybe this will work better. As I said, I don't want to crash the board and I don't want to bump those parts. No, but it seems it's working well. I'm not pressing. This part is good. Let's move to this one. Good, and we have one more side to do, like this one. Now this is a large cap here. I can't really go with this tool around it. I think we're gonna use the knife there, the blade. See this cap here I already moved. Yeah, so we have one cap in that corner that we're gonna have to replace. I think that's required. It's possible that one is from the clock. We'll see later. Okay, and now I'm gonna get the knife and tackle this side here where this whole cap is. Good. Now let's see if we can clean this and get to the glass chip. I need something else. Okay. I think it's fine. Well, let's try that method. As I said, I've never tried it, so... Can I get this? Okay, so I'm gonna use this. Yeah, and we're gonna use some solder. Let's see what we can do about it. Let's see if this works. There's nothing for us to ruin like this. Yeah, so I'm just flooding this with solder. So in theory this way we only concentrate the heat over the chip. Let me see if I can get something. I managed to trouble the oscillator there. Okay, have a problem. The board didn't stay very well. I need to grab it a bit better. Boy, so the board is very hot. Yeah, I don't know. Let me see, maybe if I come in with this one. I can see the chip coming off. Yep. Okay. So this is a first for me. This was a first for me. That looks interesting. I have a bit of balls squeezed on those caps, but nothing on the rest of the board. Interesting. Okay, so let's see how we can clean this. I don't think we broke any pads on the board. So I'm gonna get some 148, it's a bit lower meltish. And I'm gonna spread it here so I can wick this after. I think we would have had better results if I didn't have any trouble with keeping the board on the holder. So I had to actually warm this twice, but that's fine. Let me clean some of the balls that popped out. So we have some here. Let's do all around. That cap moved. I think it's fine. Okay. Now let's try to wick it. Board again fell off the holder. This is so annoying. Let me try to grab it back. Maybe right here. Okay. And let's try to clean it tiny bit. I'm gonna use a brush this time. This looks acceptable. Okay, let me raise my chair. Something broke on my chair because it's going down by itself. Okay, so let's now clean the rest of the underfill. Without bumping any part. This underfill is bad, it's worse than the one that is under the CPU. To be honest, I don't know why they use this. You're gonna see. It's gonna be very hard to prepare a new chip because I'm gonna harvest it off a donor board. And all that underfill will remain under the chip. Yeah, we have some balls there that we need to remove. Yeah, well, I don't know, I have mixed feelings about this. I think it's good. Now let's see here. So we have a component misplaced here, but we're gonna fix that. I just need to get all that crap out. And then we're gonna also reflow this crystal oscillator. Yeah, and I need to try to remove these balls here. So we have a couple of balls right here. Actually, there are three. Okay. And we have one ball here. Yeah, got it. Other ballage, I can't really see. Okay, so now that the board is still warmish, I'm gonna clean it one more time. Okay, good. Just dry it off a bit. And And let's try to handle this. This mess I have created there. Okay, let me get some solder paste. Did I just touch it with solder? I don't know. Okay, and I need a finer tip. Okay, perfect. So we have a blob here, we have a blob there, and that's prepared to be receiving a new part. Now I'm just gonna reflow a bit that area because I know I've moved that crystal oscillator and I would like to set it back in place, and maybe that cap will also fall down. Yeah, my hands are shaking, no problem. Okay, I think all is good. Now let's try to clean it one more time. Alright, so it looks good. Good. Now, the big moment, I'm gonna find the donor board. I'm gonna start by cleaning the underkill around it. But you're gonna see here, we're not gonna take care of the board. I'm gonna come with a tool and remove safely the chip, so I will not care about any of these parts. I will actually break most of them. Also, I don't care about these on the sides. I don't care about the board. Yeah, here the only thing important here is this chip. Okay, and we have this side here. Okay, good. So now, first of all, I'm gonna need a bigger nozzle. I think I'm gonna go with this 8 one. Yeah, I think it's the best for this application. I need to wait for the hot air station to stop cooling off so I can remove the small nozzle. Add the biggie. Okay, and I'm gonna use 380. And a lot of air. I'm still hitting the board all around. I'm gonna remove these parts as I said. Yeah, and I see that the chip was already spilling out. Yeah, and all the underfill is on the chip, and that's bad because it's gonna be a struggle now to clean it. So I'm gonna take it from here and use a smaller holder. The problem with this chip is that it's very thin. It's a very thin chip, we can't force it. Yeah, not even in the holder, I'm not forcing the holder too much, it's just staying there. And now I think I'm gonna go with 280 on the iron. Okay, I'm gonna add flux, like lots. And again, I'm gonna use, not the correct tip. I wanted to say I'm gonna use some low melt, like 148, the one that I have at hand. Yeah, so we're gonna try to replace that solder that is currently there. I put the iron to 280 because we're gonna have to scratch this a lot, so I don't wanna put too much heat stress on it. I'm just barely scratching with the iron. You see here we kind of get to the chip. I know some other people use blades, but I don't want to ruin the chip and I'm not very successful with the blades on the first try. So I'm gonna go slow. This isn't the fastest way to do it, but for me slower is safer. Even if we don't clean all this underfill, I need to clean some of it to make room for the balls. And definitely need more flux. Not very aggressive because I don't want to scratch the chip. But if we keep it warm, it's fine. It is a bit chirped there on the side. I don't know how it got like that. Let me try to clean it now with the brush. See the chipped side? I don't like that. Okay. Clean the holder. Okay, let's see what we got here. We have some MacBook chips here from a previous repair. We clean the table just a tiny bit. Okay, and let me get these parts off. Good, so let's see what we have. Yeah, it is chirped on the side here. That's weird. How does it look from the other side? Not bad. Maybe I chipped it when I was cleaning the underfill around the chip before removing it. I don't know. But we're gonna use it like this for now. Let me set it somewhere in the middle. Okay, maybe like that. So let me prepare some solder paste, as I need to dry it. So I'm gonna take some and I'm gonna dry it on a paper tissue. Yeah, and this needs to be very dry. Good. So now let me find a stencil. What do I have here? Oh, I have here the iPhone 14 stencil. Oh boy, this is so dirty. So which one do I need? Is it this one? Yeah, I think it's this one. Good. So this is clean. That's fine. I'm gonna set the hotter to 330. And I'm gonna add the solder paste here. There's a magnetic stencil. Well, it's a magnetic mat under this stencil, so that helps a lot. So let's try to reball this one and see what we get. Goes a bit slower with this big tip because the flow is not that great as it is with a smaller tip, but we can get the job done. Okay, so I have a problem here. I don't know if you can see it, but I think there was some dirt here. Let me add some flux and try to reflow it one more time. See if that will settle that ball, otherwise we're gonna have to do it separately. So I think it's fine now. Let's remove it. Now we have all the balls there. Let me clean this while it's still warm. Good, so let's do a quick reflow on this one. Okay, perfect. Now let me add some flux on it while it's warm, because this will help us solder it in place on the board. Good. Now, where's our board? Our board is right here. Let me set this to 350. Okay, and let's see what the orientation is. Yeah, so it will come like this there. Good. I need to somehow line it. It's gonna be a bit difficult, but I need patience. I think it's good. I'm gonna put a piece of copper on the CPU so I don't heat it up. Well, I'm not gonna heat it up because I'm coming with the air from the opposite direction. I'm gonna go from above because my air is a bit too high, and I'm afraid that it's gonna just blow the chip away. I think this is fine. Bueno. Okay, so let's cool off this board, and then I'm gonna clean it a bit. So you're not gonna see for a moment. I'm gonna pause this video. Good, so I cleaned the board. It's now factory, right? The clean was quite okay. Board is cleaned. Now let's see. As I told you yesterday when we started working on it, I didn't like the fact that the PMIC had a short and the CPU was also heating up. So I'm afraid that a bigger line got to the RAM or some other parts of the CPU, but we're gonna test. So we have the second supply. The first one, the first thing on the upper left corner is the multimeter, and then we have the supply, and I'm gonna turn it on in 1, 2, 3. Then we have 1.8 amps current draw. That's bad. That is really bad, because obviously we did a good work here, and there's no shorts over here. Yeah, let's see what it's up. 1.8 amps. Oh boy, I'm afraid this is going to be the CPU. Yeah, and let's see what hits up. So turning the supply, 3, 2, 1. Nothing here. Nothing here. How is that possible? So we see heat here, but this heat we see it because the bat line is transformed in main over there. So do we have a main short? That's really interesting. I should have tried this before soldering on the chip. Yeah, so we see the heat coming from that area here. But yeah, that's weird. Let me inject on the main. So let's see. Let's find the main. So this is main. Good. Let me rotate it like this. And let me find a proper place to inject. First of all, let's connect the ground. Okay, so I have a ground there. And I need the main line, which is these 3 cups here. These 3 I'm gonna use here. Good. Now, let's go back to the camera. I'm gonna power on the second supply. This is freaking annoying. Let me fix the second supply too. Okay, so it's the last one on the right that you see. Power it on. I have 0.8 volt. And I'm gonna inject here on these caps. It's only taking 280 milliamps. That's weird. So it's like not a full short, but what is heating up? I'm gonna increase the voltage to actually the main voltage to 4.1. Yeah, and let's do it like this. Still get hit there. Why? Did I... Is it that chip or the other one on the other side? How is this possible? Was that chip damaged maybe before? Okay. Okay, we might have a shot at this. I don't like this type of multiple issues. But yeah, if the CPU is fine, then I'm gonna take the chance. Yeah, I'm gonna try to remove this shield. I will probably fuck up everything there because of my shaky hands. Okay, I don't like the way the board sits here, so I'm gonna put it like this. I usually cut this one. Yeah, see why? I fucked up this chip. Oh boy. That's freaking annoying. So let me get this off. Yeah. And yeah, let's see if this was heating up or it was something else. Okay, let's inject now. Oh, I need the thermal camera again. So if we inject in the battery terminal, it's not actually this side heating up. It's the charging, I see. How is that possible? So here, do we have a main? Let me see 1 second. So this is a main. Yeah, and we have these as main. So these caps here, these are main. Let's get back to the camera. So look, see, if I inject in the battery, I get hit on the other side. If I inject here on the main, the same hit comes from the other side. So let me fix this first, because I bumped that chip and I need to put it back. Can we put it back without reballing it? Okay, let's see the chip. Yeah, I should reflow this one too. You can't see nothing, right? Let me see first where it's the first. So the first is in the first pin. Do I hold it? The first pin is upper right. Good. So I'm really not in the mood of reballing this one. I'm gonna try to make a mess. Good. No. Why are you struggling here? I can't really see where the um, mark on the chip is, so I need to clean it somehow. Yeah, so I think it's like this. Good. I couldn't see, but it's right there. Okay, I'm gonna add some flux. I'm gonna grab the chip. Yeah, place it there if I can. Oh, this is so fucking annoying. Okay. It's where it should be. Now let's rotate the board. Let's see what happened here with this charging, I see. So pin number 1 is here. Because I had no issues with it. Well, apparently none. But let's remove it. Good. Chip is removed. Let me clean that a bit. This phone is weird with its issues. Okay, let's wick that. Let's wick it. Do I have some wick around here? Have some old one I can use. Oh boy. This was still on 280. Since we cleaned that underfill. Okay, so clean complete. Okay, let's see, do we still have something on the main? So if I inject now, you remember on the main we had like 74 milliamps. current row for some reason, so this was main, right? Wait. Don't let me do some mistake. Let's check again. Yeah, so these 3 caps here are main. If I inject now, I don't have any consumption. That's good. Okay, so that's interesting. Let's replace the charging IC. Don't have it on the board that I used for the PMIC, but let's see if we have it on another board. I have here another one. There's another one right here. Okay, let's grab it from here. Good. Let's do some reballing. Yeah, I'm gonna use some leaded solder now, so it's not a low melt. Perfect. Let's do some cleaning. I'm gonna clean first the flux with a dry cotton swab. And now I'm gonna use some with alcohol, with IPA. Good, all clean. Let's go with it on the slimmer side and reball it. I need to clean this. Can't stand it. My tweezers got so dirty and sticky. Okay. And let's find the proper stencil, the proper, is it this one? Yeah, I think it's this one. Right here. And give it some paste. Okay, and let's make some balls. Again, 330. Okay, perfect. In the stencil while it's hot. Good. Now reflow this one. Good. Now add some flux. Good. Now install it on the board. I lost it. No biggie. Now let's see how does it look. It looks good. No dirt on it. So this one comes in like this. Okay, I think this is good. Yeah, so this was very fast because that area of the board is very narrow and it takes only just some little heat. Okay, let's clean it. Good. Now let's try again. Man, I'm nervous about it. I am nervous about it. So let's see. I'm gonna connect the supply right here. Okay, supply connected. Turn on the supply in 3, 2, 1. And we have no more power consumption. As you see there, it's 4.1 and 0 amps. And let's try to boot it. I never know which is the... Is this the one? No? This one? No? Here? No? Here? None? Oh, this is bad. This is bad when we have no signs of anything. Let me see. So this is button. Can show you what I'm looking at. Button, volume, NFC. Ah, this is the one. So it's this one here, right? And if I short it, I have nothing. And nothing means a non-working PMIC. Let's check there. So I'm gonna set the multimeter to DC volts. Good, let me find the leads. So on that pad we should have like 1.6 volts, something like that. And we have 1.7. See? So why doesn't it start when I prompt it to boot? What's going on here? Is it my tweezers? Man. This is weird. So again, I'm on the tweezers. 0.5, what the fuck is that? Zero 5. What is going on here? So again, one point seven, and if I short this to ground, yeah, it starts. The phone starts. Oh, yay, we have boot. Okay, good. Let's take the screen. Let me fix this one because I fucked it up a tiny bit. So let me connect the screen and see if we get picture. Do we have picture? Understand why my tweezers didn't work, but I don't know. Turn it on again and let's try again with the tweezers. Yeah, now it works and we have an Apple logo here, right? Look at that. Apple logo. Yeah, I think it's rebooted. Why? It's in a boot loop. It's in a boot loop. Something is not right. And I don't see any weird power consumption, any weird behavior. Fails. And I think that CPU is fucked. I really believe the CPU is fucked. When it tries to start, it fails. And it is the NAND because we can see how the power consumption goes to 2 amps and then it goes off. Well, this is too bad. This is a bit too bad. Okay, so just to give it another chance, although I shouldn't have to, because we've already worked too much on this one, and I think the CPU was affected by the initial issue, because you saw you saw that it was heating up pretty bad. So I've removed the PMIC that I've installed. I've also prepared a new one just to exclude the PMIC, maybe I broke it or something. But first I want to measure some of the lines here, so I'm gonna do a diode mode reading. Let's go. Okay, like this. Like this is good. And let's start from the beginning. I wanna see if there's any weird issues, so we start with this one, should be 3 to 4, okay. So this is OL, and this is OL, that's good. Then we have a ground, then we have 218, that's good, 3 to 4, that's good, 2 and 2, 2 and 2, I lost my ground. So 2 and 2 here, then we have a ground here, correct, then 3 to 4, well, it's good, then 338, is good, and then another ground, good, 181, 181, did I make any mistakes? So 1, 2, 3, 4, 5, 6 from the right, 1, 2, 3, 4, 5, 6. So this is 0.268, the next one 0.32. 32, yeah, so it's good. 3 to 4, this is the fifth. 181, yeah, this is ground, correct. 338, no, 338, no bueno. 338. So 338, that's 1, 2, 3, 4, 5, 6, 7, 8. The 8th one. 1, 2, 3, 4, 5, 6, 7, 8. This is a very low reading. 0, 0, 4. Let me grab the one, the donor board, from where I took that the chip, and let's see here. So here, 1, 2, 3, 4, 5, 6, 7, 8. 8 is also low. 0, 0, 8. So why are they lying on the board view? That's an iPhone 14 Pro. Because this is the same board. 1, 2, 3, 4, 5, 6, 7, 8. This one 3, 3, 8. So this one goes to this is a RAM line. It's a RAM supply. Nah, that can't be correct. Let me open a 15. Let's see. On a 15, we're looking for a similar line. 1v8 and this. Let's see, this one was back 1v1 VDDH 1v1 1v1. Do we have on the RAM on 15? 1v1, this one. We have no diode mode readings here. Oh boy, this is crap. Let's go for a 13. Yeah, this is gonna take a while. Okay, 13, come on. 1v06. This is something kind of a similar. 1v06, yeah, 32. So we have a small reading, so this is crap. The drawing, the markings, well, the markings. 14 Pro Max, let me rotate. Let's close the others. So the readings here are not great. So because they are not great, to be honest, I don't even want to look at them, because I cannot trust them. Let's see this side here, on the CPU side. So let me try to grab another ground. And let's see, so we are 1, 2, 3, 4, 5. 5 is 2 and 2. 1, 2, 3, 4, 5. 2 and 2. Almost there. The next one 3, 6. The next one should be 0, 1, 45. And the next one is ground 145, and they say 66. Well, we can't trust this, so fuck with it. Alright, so let's just replace the PMIC with the new one. The new old one I've prepared here. I can grab it. Let's see what the orientation is. Yeah, so it should be like this. Like this. So this is a new PMIC from a different board. I've removed it, cleaned it, reballed it. I didn't record it because we already have one example that I did with the previous one, so let's try with this one and see if there is any change. Oh, boss mag. Okay, boards are fine. Let's put it back. There was too much flux. Way too much flux. Okay, so it went back into place. If I didn't bump it too much. Now let's pull it off. Okay, let me clean it. You can see it for the moment. There's no biggie. Nothing special happening. Just me brushing the board. Good. So how does it look? Yeah, not too shabby. Let's see, do we have a short? If we connect the supply, I'm gonna have to clean the board afterwards, but we can test it dirty like this. So, I have 17 milliamps, no 1 milliamp, that's weird. Why? I have no idea. So let's try again. Turn it off, turn it back on. 1 milliamp current draw. Why? Don't ask. If I prompt it to boot, no boot, nothing. This is the same issue like before. Let's put the multimeter in voltage mode. And let's see, do we have here 1 point something? 1.6, yeah, we do. Prompt it to boot, nothing happens, see? No boot. Why? So why did we last time had a boot? We had the same issue in the beginning. So something is taking 5 milliamps. 5 milliamps, I have no idea what. 1.6, short it to ground. No, it seems to be booting. Staying at 120 is not a good sign. I think the CPU is freaking something wrong with it. It's doing something now. Power consumption is too low. So if I turn the supply off, turn it back on, it's so just started. Why? So turn it off, see? I turn it on and it goes straight to 160 milliamps. Let's see what is getting hot now. What's taking the 160 milliamps? Also that initial current draw was really weird. Don't know if I should pause the video or not. Maybe I should. Desktop. Connect camera. Let's see. Okay, so I'm gonna turn on the supply. Yeah, it's the PMIC. PMIC. Just ignore the second supply that shows 8 volt, 9 volts because that's my phone. Oh no, another phone charging. PMIC, so something is wrong with the PMIC. Okay, so this is the third chip I installed. Apparently the second one had an issue. So I installed the third one. I've set here the supply. I've already tested to see if there is a short, and there is not, as you can see there. So let me install the screen and see if we get a full boot or we are still in a boot loop. Yeah, so I'm gonna turn on the supply. Let me get the tweezer to try to power it on. Okay, it looks like a normal boot behavior. So far we got an Apple logo. And let's see what is going on. It looks a bit better than the same. Apple logo went away and it restarted. So there was nothing wrong with my initial chip. There is something wrong with the phone. See? Can it be something related to the NAND? I don't know. It's worth trying to resolder the NAND maybe. Because other than that I have no idea what the problem could be. So the NAND is on this side. I can only think that maybe something happened to it. Or maybe something happened to it from the drop, as it happened to the PMIC. Yeah, so I can't see any signs of too much heat. There's no signs here on the NAND of too much heat. Yeah, so I can try to rebuild the NAND, that's no biggie. Let's do it. I'm not even gonna film it, and this video is gonna get extremely long. But I'm gonna do the NAND also, just to be at peace. I still think it's a CPU issue. Good, so we have prepared the board and the NAND is rebuilt. And we can do it together. 50. I think I mentioned before, right, that I don't think the NAND is the problem. And I think the phone is actually fucked because of the initial PMIC issue. I think the CPU got the hit. Alright, but in the name of science we can also try this. This is gonna take a long time because it's hefty. It's pretty hefty. Yeah. Bueno. Let's hope we didn't mess up with the other stuff, like the CPU. The PMIC being soldered by us, there's not such a problem. Not a huge problem with that. Okay, let me clean the board first. I'm gonna pause this for a second. Ta-da! We have a clean board. Good. Looks good. I don't like the way that clock chip sits. Yeah, but whatever. Who cares? Let's see. Is this the proper one? I think this is. Okay, let's start the power supply. Okay, no short. Let me get the display. Prompt to boot. It doesn't want. Is it my freaking tweezers to blame? No, it doesn't boot again. What is going on here? Where are the multimeter leads? Do we still have 1.6 here? .5. Shorting down. Not booting. This is crazy. So we literally did anything, just move the NAND over, well, reball it. So if I have 1.5, see, I short down, but there is no boot. So now it should boot. No, it doesn't. This is crazy. Yeah. This is insane. Why is it doing this? Do we maybe have some coils? Okay, let me handle that that clock chip, well, crystal. I don't like the way it stays there, like hooked on one side. Okay, let me see, I have another one here. Is this? Yeah, it is. Oh, for fuck's sake. Okay, let's cool this off. Oh boy, so hot. Or maybe the CPU is disconnected, or there's a problem with it, I don't know. I think the next step would be a full sort for this board. Okay, let's see. Turn off the supply. Turn it back on. Yeah, and now we have a fucking short. That's incredible. Alright, so I went an extra mile for this one and I decided to do a full swap. So I'm gonna move the CPU, the NAND, the Wi-Fi chip and the logic EPROM to a new board. So this is the CPU, I've already prepared it. I have here the NAND. Yeah, you can see the NAND here. And I also have the Wi-Fi chip here. Good. This is perfect. So I have prepared a new board. Let me take it over here. Yeah, so this is the new board where I have, it's a 14 Pro Max. I have removed the original CPU. You see that this is this has the original PMIC, and I have removed the NAND and the Wi-Fi chip. It's already cleaned, and the logic EPROM I've already moved here because I don't want to reball it, so I just move it. Now a board, if we want to test it, if it works properly, we need to apply power and see the power consumption. Without the NAND, without the CPU and without the Wi-Fi, we should have between, I don't know, 10 to 15 milliamps power consumption when we prompt the phone to boot from the button, right? So if that's the case, then we have properly a good donor board. Since I opened, I started the power supply, you see on the left, the one with 4.1 volts, and I'm gonna prompt it to boot from here. Yeah, and I have a constant 13 milliamps current draw, which is good. So this is what I was expecting. Now let's start installing these parts. I need to see the orientation. So give me a second to have a look on the board view. Okay, so the Wi-Fi chip is top right. Top right, I'm gonna start with that. I'm gonna add some flux here because there's no flux on the chip. Okay, hope it's enough. And yeah, I need to change the nozzle. I need a bigger nozzle. So I'm gonna take the 8 mils nozzle, good. And I'm gonna use like 350 60R. 60 it's a bit too much, but I think we're gonna use this for all of them. So I set the top right. Okay, we put it like this. Yeah, I think this should be fine. Or not, maybe like this. Okay, you can't see very well. Let me pull it like this. This is quite a hefty chip, so it's gonna take some heat. I've just put a little bit too much flux. Yeah, but I saw it go into its place. I bump it a bit. Yeah, it's fine, good. Let's move to the NAND. And let me add some flux. I'm gonna try to put not that much. Okay. And let's see, the NAND, I said it's top left. Good, so it should be like this. Yeah, and now we're gonna see if we have a problem with the CPU, or maybe the board was damaged due to the crack that it had the phone initially. So this chip, you won't be able to see it whole because it's very large. Good. The RAM is soldered, and now I want to actually cool it off. I want to cool off the board because I want to test again, see if we have any shorts. Because next is the CPU that we install. And I just want to make sure that everything is fine with the board before placing the CPU. Good. The board is still warmish, so we might have probably a bit more than 13 milliamps that we initially had. So started the power supply, no short initial, and prompting it to boot we get 15, which is still good. Okay, so we can jump to the CPU. And for the CPU, because I already have those with low melt, like the Wi-Fi chip, and on the other side I'm gonna use a holder so I don't press on down. Yeah, let's put it like this, maybe. Yeah, again, you won't be able to see it all, but that's no problem. Good, so I already have flux on the CPU. Okay, and this one comes like this. You saw the CPU looks perfect, no rip pads. Everything went nice. I'm gonna put a piece of copper here over the PMIC so I don't bother it too much with the heat. I'm gonna hold the CPU in place, and now I'm coming with hot air. There's a bit too much flux when going further away with the air. Because I don't want the CPU to move, and it has already moved. Okay, let's see. The balls are still intact, so that is fine. I'm gonna let it cool off for a second. Let's see what happens when you have too much flux. I really am not in the mood to reball it again. Yeah, so I'm trying to position it back. Probably like this. Good. And let's go again. If I saw it going into place, let's see if it moves already. Yep. I think it's fine. Okay, so it is cooler. See? The soldering looks good. The reballing, it's excellent. Factory. Good. So let's power it on and see. Well, at least let's, without the screen first, I'm gonna see if it has a normal boot behavior on the supply. Good, so I'm gonna power on the supply. 3, 2, 1. No short. Okay, and let's prompt it to boot. 3, 2, 1. Oh, it looks good. No, it doesn't look good. So now it looks like it's in DFU mode. And it's in DFU because it doesn't see the NAND. Okay. I might have an explanation for that. I think I'm missing a part here, see? Here, let's see what that is. It's possible that that part is important. 1, 2, 3, 4, the fourth one. 1, 2, 3, 4. Yeah, it's a filter. Okay, so the NAND was not getting the 1v24. 1v24. No problem. Let's try to get one from here. Do we still have it here? Yeah, we do. Okay. So let me get it from here. The filter is it acts like a fuse or something like that. Without the filter, that voltage doesn't reach our NAND. And that might be a problem. Yeah, so basically that's a sort of a zero resistor. Good, I've got that. Now, let's see. I'm gonna place this up here. If I can somehow. So I can prepare the pads. Yeah, so whenever the phone doesn't see the NAND, it will enter DFU mode. Okay, let me add some solder paste there. I'm not gonna put too much, and I need my small tip. I think this is the smallest one I have. Doing this will help soldering it because it's 183. Well, it's a 6040 leaded solder. So I think it's about 183. Now let's see how we can solder this without disturbing the NAND, without it flying away. And without reflowing the CPU. Good. That is perfect. Okay. Now I have to pull off the board again. So I think I've moved that part when I cleaned the board. Forgot about it. Okay, good. Now let's try again. I'm connecting here the power. So I have the power connected. Power on the supply. The board is still warm, so the consumption might be a bit bigger. So let's see how it looks now. Still in DFU. And that's no bueno, it is still in DFU. Okay, let's see why. Bine, nu vreau. Let's see why we are still in DFU. That's not good. So, we have the multimeter there. Let's see, do we have power on that? Yeah, so we should have 1V24 here. Yeah, we do, on the output, and this is the input. Good. Let's see these caps here. 124, 08, 08, 08, 08. I'm just measuring the caps, sorry, you couldn't see. 124, so we should have another power line, let's see. .083, 124, 2V65, yeah, this is what I'm interested in, but I don't have anywhere. Oh yeah, I can test it right here. So it's this big cap here. Well, that's no bueno, so I'm testing on this cap. 262, it's okay, it should be 265, so it's good. Now that cap here, I don't know what it is. Let's measure it on the other side. So on this side, I'm interested in a cap that I might have damaged. 1, 2, 3, so it should be this one here. 07, yeah, so it's fine, the line is fine. So why? I'm gonna stop the supply. And now I wonder why we are still having issues. Now, when I installed the CPU, I damaged a few caps here and I replaced them from a new board. And those caps were the PCI Express line caps. So let's see. This one, yeah, I damaged this one, but this one we don't really care. This one, oh no, this is AP2 baseband. We don't care about that. AP2 WLAN. We don't care about that. So where are the caps for the NAND? The NAND should have some PCI Express lines that go to the CPU and should be OL here. So are these the ones? Yes. These, let's see, where do they go? Okay, so they are here, 1, 2, 3, 4. Yeah, so those caps, they are all NAND, 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 RX and TX. Okay, let's see them. So it's the 4 over here, right? And am I holding this correctly? Yeah, I am. Okay, let's put the multimeter in diode mode. And let's see if we have a connection. Oh, fuck, now the multimeter decided to throw an error. Yeah, but it still works. Good. Okay, so we are interested if we have continuity or some reading on both sides, because on this side is the CPU. Yeah, this is good, this is good, this is good, this is good. Yeah, so I have the CPU on this side, and on this side we have the NAND, and it all looks good. Okay, so where's my camera? Come here. Why would this be in DFU? So I have another idea. It can be in DFU. So first time we had an issue with that NAND line, but then this could be maybe not actually a 14 Pro Max but a 14 Pro board. So I'm not sure. I had it in the drawer as a 14 Pro Max. But we can check that by looking at the board ID. pin resistor, right? So if we go here, I'm gonna search for ID, yeah, and it should be this one. So board ID resistor is this one. 1, 2, 3, 4. 1, 2, 3, 4. The fourth, right? So if we do like this, okay, let's measure the fourth resistor. So if I measure the fourth, I get 30 something kilo ohms. I need to do it somehow so I don't touch the rest of the stuff. 1, 2, 3, 4. 20 something kilo ohms. Let's see the original one. So this is the board where I got the CPU from. And let's see, 1, 2, 3, 4. This is 1 kilo ohm. Okay. So this might be our answer. That's gonna be a bit complicated to remove. Okay, let me first see what. Need a smaller nozzle here. This could be an answer why we are in DFU mode. If we would have connected the phone to the computer, I think it would show a 14 Pro instead of Pro Max. So how do I remove that small resistor there? I'm gonna use some hot air and I'm gonna use the small tip. I don't want to hit it. I don't want to hit the board too much. Yep, because the CPU is also with 183. Yeah, so resistor is removed. Let's see if we can measure it. It's right there, out of the circuit. I think it should be like mega ohms. Yeah, it's 1 mega ohm. See, it doesn't even fit the screen. Good, so I think we're on the right track. So for this, for 14 Pro Max, we need 1 kilo ohm. Let me clean a bit here and add a bit of solder paste. You know what, I think I should add like a lower melt. I'm gonna add 148 so I don't heat stress the CPU too much while attempting to solder the new resistor. Yeah, so we learn a lot from this video actually. Can I have some paste there? This is not that wet as the 183 is. So let's see if I can make a small boulder that I could solder on. I'm gonna add a bit of flux and let me see if I can get some more solder on the tip. This is too much. Okay, I think that's good. Let me clean this. Perfect, so now let's borrow the resistor from the other board, from the original board. I just want to clean this underfill first, so I get it like clean. Okay, let's go. Okay, let's not lose it. And a little bit of focus here. All the flux went under the CPU. I don't like that, but this being a 148 solder, it should melt faster. Good. Good, good. Good, good. Let's put some alcohol. It's gonna help it cool faster. Where's my knife? Here. So we had all sorts of issues with this one. Yeah, it wasn't an easy repair. And let's try to pull it off. Who would have thought about this? Write me in the comments. Would you have investigated this board ID stuff? Let's see if this was the issue and if the phone is booting or it's still on a DFU consumption. So power supply is on. We get the tweezers and power it on. Yay! We get a boot. Good. I'm gonna turn it off and I'm gonna get the screen because now it's the big moment. Yeah, so the board ID resistor is very important because if it's not correct, the phone will not boot. Okay, and we have an Apple logo. Let's see. So this one was boot looping before. Let's see if we get a login screen now, or it will still boot loop. Think about here, it was restarting, but it's a good sign. It hasn't yet. Yes, we have a screen and we have touch. This is perfect. Good. Yeah, so this was very interesting. Now I'm gonna have to clean the boards and solder them back together. There is a face on that one, but I'm not gonna continue with this. I think I'm gonna leave the video for us here, and I think this is a very good tutorial about investigating a phone that has no power and no charge, right? It was a very complicated repair, but we made it through. And yeah, I don't know, give me a like, subscribe if you didn't already, and we'll see you next time. Bye for now.